This lesson is going to be about the half-angle formulas, the double-angle formulas, and the power reduction formulas. Now, you can either pause and copy down the half-angle formulas here, or they're on your formula sheet if you got the full formula sheet from me. These are the double-angle identities, and again, you can either pause and copy them down, or they're on the formula sheet I gave you. These are the power reducing identities, and these are not on your formula sheet, so you will need to copy them down. Now, the one thing about this lesson is in the original schedule we had 2.5 days scheduled for this lesson, and we only have 1 day for all of these new identities. And so the double angle, the half angle, and the power reduction identities, I will give you these formulas on the board during the test. Now, you're not going to get all the formulas on the board, the basics, Pythagoreans, that kind of thing, cofunctions, odds, evens, you'll have to remember those. But these new formulas will be on the board. So in one type of problem, you'll be proving the new double angle identities. Like, for example, one of the double angle identities for cosine, so the cosine of twice the angle is 1 minus 2 sine of the angle. And if I wanted to prove this, I would use my old identity, that's cosine of u plus u. And then, you do have to have this memorized, that cosine goes cosine, cosine, sine, sine, and cosine has the same sign, cosine has the opposite sign. And so u. So this is cosine squared u minus sine squared u, and if I want to write it all in terms of sine, I can change this cosine to 1 minus sine squared by the Pythagorean identity, and now I've got 2 sine squareds, so 1 minus 2 sine squared u, check, that's an identity. So part of your assignment will just be verifying identities or verifying the new identities. So essentially you don't actually need to know them to do these, you just need to be able to prove them. Let's take a look at a power reduction. Cosine to the 4th x is equal to cosine squared x squared. Now, if you copy these down in your notes, you'll look at one of the power reducing formulas was that cosine squared changes to 1 plus cosine 2x over 2. Now that's still squared, so we'll have to FOIL that. That's 1 plus 2 cosine 2x plus cosine 2x squared over 4. And now that's 1/4 plus 1/2 cosine 2x plus 1/4 cosine squared 2x. And then we would need to apply that power reduction rule again here. So we have this 1/4 and the 1/2 cosine 2x stays the same, but then this becomes 1/4, and using this same power reduction, the cosine squared of 2x becomes 1 plus the cosine of 4x over 2. Now the phone rang and I lost my concentration, but we should talk about why we're doing this. It's kind of like this. If you had x to the 4th is equal to 16, you could take the 4th root of both sides of the equation and get x is equal to 2, but that's only one answer, and an x to the 4th equation really has 4 answers. Some of them are imaginary, some of them have a multiplicity of 2. If you have a 4th degree equation, you have 4 answers. So doing this power reduction thing is going to give you access to all of the different answers. So now we have 1 plus cosine of 4x over 2, and so we end up with, let's see, this 1/4 plus this 1/2 cosine 2x plus 1/4 times 1/2 is 1/8. And then 1/4 times cosine 4x over 2 is cosine of 4x over 8. And if we reduce that more, I don't know, I guess you could pull 1/8 out. Oh, and this 1/4 plus 1/8 right here needs to be combined. So that's 3/8. So if you pull a 1/8 out, those two boxes come out to 3. So like this box and this box make up 3/8, so there's a 3. And then you have the 3, if you pull it 1/8 out of the 1/2, let's see, 1/8 times 4 is a 1/2, so this piece becomes 4 cosine 2x. And then this last piece right here becomes cosine 4x. Now, we're not solving this, we're just reducing this down so it had a 4th power here, and now it's all single powers down here. And that can help us later on, because if we're solving something in calculus and we need to have all the answers, we've got access to doing all of them. Now that was sort of horrible. Most of your problems are going to be much simpler. They're either going to be prove identities like the first example, or they're going to be to use something like a half an angle identity. Like if you wanted to find sine of 15, one way to find sine of 15 would be to go 45 minus 30. But another way to find sine of 15 would be to take the sine of 30 divided by 2, because that's 15 degrees. And so, now remember, since we only have one day, you don't have to memorize these. I'll just put them up on the board. And the sine of u over 2 is equal to plus or minus the square root of 1 minus cosine u, 30, over 2. So the sine of 15 is equal to plus or minus 1 minus the cosine of 30. Cosine of 30 is the square root of 3 over 2. So 1 minus the square root of 3 divided by 2, all divided by 2, under the square root. So this is equal to 1/2 minus the square root of 3 over 4. All under a square root, which simplifies to the square root of 2 minus the square root of 3 divided by 2, plus or minus. And so for these types of problems, you're just going to be, again, don't have to memorize these formulas, copying down the formula, doing your exact value thing, simplifying, getting the answer. There will also be problems that involving solve an equation. So let's say you had to solve this equation. When is sine of 2x equal to cosine of x? Well, let's say I used my double angle. One of my double angle identities is sine of 2x is equal to 2 sine x cosine x. So when is 2 sine x cosine x equal to cosine x? Let's get that equal to 0. So that's 2 sine x cosine x minus cosine x. And then if you look at these, they have a cosine in common. So that's cosine times 2 sine minus 1. So this is true when the cosine is 0 or when the sine is 1/2. And the sine is 1/2 at 30 degrees and at 150 degrees. And the cosine is 0 at 90 degrees and at 270 degrees. And so if you were to be all good and make all of your answers in radians, your answer would look like this: pi over 6, 5 pi over 6, pi over 2, or 3 pi over 2. And that would just be if all your answers were between 0 and 2 pi. If they ask you to give all the answers, you'd have to bust that out and add the whole plus 2 pi k thing as well. Okay, so your unit exam is going to be a week from hopefully the day you're watching this, Tuesday. And you can expect to have a few half-angle or double-angle problems on your test, but I can guarantee you right now, I'm making you a promise, if it's on the test, it'll be one of tonight's homework assignment problems. So you'll know exactly what to study for 5.4. For 5.3, you need to go back and make sure you have those rules, sine, cosine, cosine, sine, sine has the same sign for the sine sum rule, and cosine, cosine, sine, sine, cosine has the opposite sign. So this is cosine of alpha plus beta. This is sine of alpha plus beta. And after you do that whole sine, cosine, cosine, sine thing, go back and fill in the A's and the B's. After you do the cosine, cosine, sine, sine thing, go back and fill in the A's and the B's. You only have to have your trig identities memorized through 5.3. The 5.4 ones will be on the board. And what else can you do to study? If you need to retake that quiz on 5.1 to 5.2, please come in and do that. I would say that'll make up about 60% of your test score. Maybe 50. Good luck. Thanks. Bye.